The broadcast is now starting. All attendees are in listen-only mode.
Hey, good morning. My name is Lance French. I'm the business manager for W&M Environmental, a division of Braun Intertech, and I would like to welcome you to our last webinar of the year, Environmental Cost Budgeting. And our experts for today are W&M's Gene Murray and Andy Adams. Thank you for joining us today, gentlemen.
Thanks, Lance.
You can say thank you.
Hey, Lance.
Gene has never been on a webinar before, so we're going to have to show him the ropes, Andy. So I don't know how he's not been on one. But before we get started, I wanted to go over a few housekeeping items. If you have any questions, please send them to me through the chat tab on your GoToWebinar window. If we don't get to your question, and I don't think we ever have not gotten to your questions, but I will make sure that Gene and Andy see them, and we will get an answer to you as soon as possible. We are recording this webinar, and it will be available to rewatch on our website soon, probably tomorrow, along with the slides, and I will send you an email with the link when they are made available. So let's get to it. Let me introduce our experts on cost estimating, Gene Murray and Andy Adams. Gene is a project geologist.
Yes, I'm a hydrogeologist by training. Graduate of the University of South Dakota, the University of Texas at Dallas, and of course, University of Nebraska, which is why the Herbie Huskers up there.
And don't forget UTD, right?
I just said that.
Oh, I didn't listen. See, I'm already bored. All right, Andy, what about you? KU?
Thanks. So I guess I consider myself a fate and transport chemist, at least by training. So I've got an undergrad from the University of Kansas, hence the Jayhawk that's up there, and the University of Minnesota tend to have a lot of projects with spills with long-term and short-term cost estimating and things like that on remediation projects. And so then I'm an associate principal, and I sit in our Houston office, and I have some regional control over what we call our Gulf Coast region in the state of Texas.
Okay, excellent. So speaking of estimating, how many wins are Nebraska and KU going to have total for the year?
Moving on.
Okay.
I would take the under.
All right. So, okay, we're just going to jump right into it. What's the difference between classical deterministic statistics and I got to say this wrong, Bayesian probabilistic statistics? Okay, Andy, I'm going to be honest with you. I don't even understand the question, so I'm going to just hand it over to you. Go for it.
Easy for you to say,
I mean, yeah, so you might want to restate the question.
So really this question is getting at, we're going to talk about today classic and Bayesian statistics. And you're going to be a little bored during that point. Just stick with us. There's a method to the madness. So we're going to start by covering how's it done, or we're going to look at how the sausage is made, and this might be a little boring, but stick with it. It gets exciting. Well, as exciting as this stuff does. Then we're going to look at some examples, and then we're going to give some explanation of the importance. And so I'm going to let Gene tackle the hard question, which is that one.
Well, we get asked this question pretty much on a daily basis. How much is this going to cost me? And I think we, in our daily lives, see this every day. How much is this going to cost to paint my house? Or how much is this going to cost to fix my car? And this time of the year, actually, you're seeing a lot of classical statistics about polling for things like political office. So this candidate leads this other candidate by 2 percentage points, plus or minus 3 percentage points. So are they in the lead, or are they not in the lead? Well, they're kind of in the lead, they're kind of not in the lead. So how we're going to relate that to is environmental cost estimating, because again, our clients are going to want to know how much is this going to cost me to clean the site up, for instance. So let's go on to the next.
I'm going next, sorry.
And then the other way of doing this is Bayesian statistics, which has a lot of similarities to classical statistics, but the key in the difference is we can use the expert's belief in a cost estimate. So we're going to work through a few examples on that, but how I use it in daily life is if I'm talking to an engineer who hates to give any kind of estimate on probability, and I say, well, how big is that pile of soil over there? And they'll say I can't tell you that number. And then I'll say, is it more than 500 cubic yards? And they say, no. And I say, is it less than 50 cubic yards? And they say, no. So there I have at least a range, so I can use their expert knowledge from looking at the pile of soil to get rid of that uncertainty. Of course, we would go in and measure how much cubic yards there are of the soil.
And so really the driving factor here with Bayesian statistics is, there is an uncertainty around the mean, and we put a probabilistic curve to that. And some days you put the curve on there if you're estimating, and some days you have data that establishes a curve. And so if you look to the top right on this picture, you'll see the curve to the right is a very low uncertainty curve. It's a very normal curve. And all that really means is there's very little tail. And so the tail is out to the right and out to the left, and it looks at those really small costs are very unlikely to happen, and those really big costs are very unlikely to happen. And what's likely to happen is what's in the middle of that curve. Conversely, if you look to the left, you'll see a very short curve that has a very long right tail. You don't like to see those curves, because as you go to the right, the cost goes up, and the longer that tail is, the worse the outcome can be as you go out that way.
So, and to put that into layman's terms, if you will, the curve to the right, the orange curve, you have a lot less uncertainty in that. You have a good idea of what's going on there, whereas the curve to the left, there's a lot of uncertainty. So you don't know how bad the situation could be.
And so one of the last points that I want to really dive into a little on this slide is what Bayesian statistics allows you to do that classical statistics do not is you can get at sensitivity. You can get at what factors matter in your overall cost estimating or your overall liability estimating. You can get at, an expected value, or you can get at known minimum values or most likely values. And you can't easily do that with some other statistics. Or if you do, they often aren't as robust as you'd like them to be.
Okay, here's a question for you. So if I'm out there listening right now, do I need to understand what Bayesian statistics are, or do I just need to trust that you guys do?
You need to make sure you have an expert that knows what they are and how to use them.
Yeah, the answer to that is really no. But why we bring it into this is we've received RFPs from clients that say they want us to use Bayesian statistics. So there are people out there that know what it is and expect that we know it.
Well, and really, you don't need to know how the sausage is made, but it's really good to understand, what the differences between those sausages are.
All right. So it's going to bring us to our first poll question. And I just saw that we had a little technical difficulty, so I'm going to launch this poll. It might show a different screen. But anyway, yep, it did. So have you seen uncertainty probability used? Have you seen uncertainty or probability used in environmental cost estimating? And the answer is yes, no, or we've never had a need to do cost estimating. So, all right. So what are you guessing, Andy? What do you think?
I'm going to bet that you're probably going to have 50% of the people say that we've never done it. Maybe not need to, but they've never done it.
And what's your uncertainty range in that?
25%.
All right. So it's open, and we are having a little technical difficulty there, but Okay. So I'm just asking a layman question because that's what I do. Is there a preferred statistical evaluation that you like to use? Do you like to use classical, or do you prefer to use Bayesian? It's Bayesian, right?
Yes.
Is there something that is there an easier one to use, or is there a more accurate one to use, or does it just depend?
Well, I think the answer to that is probably that our clients and most people really don't know the difference, and they don't. They expect you to give them an answer, and it's a little frustrating when you say, well, it could cost $50,000, or it could cost $40,000, or it could cost $60,000. Like, well, how much is it going to cost? And I think that gets a little bit of frustration. So I think they would rather you just say it's going to cost $50,000. And we would like to say that too, but we know that there's so many things that can go right and go wrong in an environmental cleanup that it's really the correct answer is to do the range.
I would think if our clients or prospective clients out there are thinking about this, you have all heard consultants give you examples of Bayesian statistics. When I go, well, it's going to cost you $50,000, but if we have more soil, or if the landfill price isn't this, or if it's hazardous, or all those if, ands, or buts, that's where Bayesian statistics comes in. And your consultant is actually being good and telling you what the factors are that will matter. But it's also hard for clients. Clients want a price, so we work on giving them prices. But those other things, everybody has heard Bayesian statistics when they discuss work orders.
See, now all this time, I just thought you guys had like a dartboard, and you just kind of threw a dart up there and said, "Oh, it's going to be this." I'm just teasing. Okay, so I posted the results. 14% said yes. 71% said no. That's not bad. That's what you were kind of thinking, right? But then 14 said that they never used cost estimating before. So what would you suggest to the people who haven't or never used it?
Well, if you don't have
they've never seen it.
If you don't have a reason to do it,
use it.
It's good not to use it. But if you've ever gone through a divestiture, a liability swap, if you've ever had long-term liabilities and you've never asked for that, it might aid your project long-term in talking through that and asking about it.
Well, and we're going to work through this next slide. We're going to show you that even if you get a cost estimate that doesn't have any uncertainty in it, there is uncertainty behind it. So it's a diagram from the ASTM Standard Guide for Estimating Monetary Cost and Liabilities for Environmental Matters, E2137-17. We put that up there. So if you want to go in, it's a really good guide on everything that we're talking about today. And there is a standard in the industry. And I've been on this subcommittee. So there's been a lot of thought that went into this. And this is a decision tree back in the old days before computers. This is how we used to do it. So you'd put all the different scenarios, and it has to add up to 100% possibilities or probabilities. So at the end of the day, we'd give you an expected value of $63,000 on your cleanup. And if you can see there, going back in there, there's assumptions put into the technologies that we listed there. So is there, the possibility that using general cleanup goal, that is it 4% chance of it going to the landfill, 16% soil venting, and things like that. So those are estimates that the expert puts in.
And this is the single most easy place to see the difference between classical and Bayesian statistics. So if you look at the outcome probability, this is Bayesian. There's belief put behind those percentages by an expert. And because they've seen it before, they've done it before, or they have examples of it being done like that before. if this was classical, each one of those outcome would have the same percent chance of probability, and you would have a mean actually as opposed to an expected value. So this is done with Bayesian statistics, and it really gets at an expected value that most likely is not the mean, because you're getting the most likely event that could happen based on the expert's belief.
Yeah, the expected value and the mean are pretty much the same thing. So, but what you, those of you that love to do spreadsheets can see that, well, this would be easy enough to put in a spreadsheet. In fact, that's what we do today. So if you kind of go to the next slide, you can see that what we do.
Well, the next slide's a poll question.
Oh, it's a poll question. Oh, well, there you go.
So, okay, so I'm going to launch the second poll question here. Okay, Monte Carlo analysis involves how many calculations? And I'm sure that all you guys are very comfortable with knowing that. So it's going to be, the answers are 3, like 3-card Monte.
Those of you that are from New York, you've seen guys with 3-card Montes all the time.
Oh, I know what 3-card Monte is.
Yeah,
is that the Find a Queen? Okay. I was like, I've never heard of that one before.
Have them at
Good grief.
Cowboys games with the helmets.
Okay. As many as you want if you use a computer, and none, it's a glorified guess. So we're collecting responses. I'm going to go ahead and close this one because they're probably lying anyway. I'm just kidding.
I suspect they'll get this one.
Okay, so I'm going to share it. 25% says 3-card Monte. 25% says as many as you want if you use a computer. And 50% said it's a glorified guess. And that's probably what I would have said.
Okay, that's not what I was expecting. But
all right, so what's the answer?
It's as many calculations as you want if you use a computer. Actually, if you didn't use a computer, it would just take you a lot longer.
Yeah.
So going back, if you recall that slide before where we had the decision tree, and a lot of us that play around with spreadsheets could see that you could plug that into spreadsheets, and sure enough, what you're looking at here is a Monte Carlo analysis of that example done. There's many spreadsheets behind that that result that you see there. So that's what it looks like after a computer analysis of the Monte Carlo analysis.
And so, I think the thing here, for the folks that think it's 3-card Monte or that it's a guess, it's not a guess. You take the information that you know for different factors that are on some probability curve, and you take all of those factors and so if you have 3 factors, Monte Carlo takes a high number from the first factor, a middle number from the second factor, and a low number from the third factor. And it develops a cost. And it does that 10,000 times is the normal one that I see. So basically it develops one big probabilistic curve for you that gives you a total expected cost, and then it has percentages associated with how much that overall project may cost you.
Well, and you're right. It's almost infinity of the scenarios. So the scenarios is what you're getting at is, well, what's the likelihood of this scenario, and then this scenario, and this scenario, and this happens. So it's kind of all related. There's, as you can point out, there's many software programs out there. The one I use and was trained on was Crystal Ball, but there's many of them out there.
Well, and one other important, two important drivers, or at least things on this slide. We're going to go into economics now, Lance. So the net, at the top right circle, you'll see net present value. Net present value is a very specific term in finance and economics, and it basically drives that today's money isn't worth what tomorrow's money is, and today's money is worth more than yesterday's money was. So you do a number of things here depending on what you're looking at. Many of these projects will go 20 or 30 years in some cases. And so you have to have this concept of we're going to have inflation or deflation or stagflation, whatever, but it changes what the real worth of that money is. And so it's really looking at the time value of money for the project. If you're having a 2-year project, maybe that's not a big deal. If you're having a 25-year project, it gets to be a big deal. And then the other thing I want to point out, you'll hear some people call this kind of statistics or Bayesian statistics of destruction. And they use that because a lot of this isn't necessarily permissible in court, and people don't like the tails. So if you look at the total expected cost on the right, they don't like that right side of this graph. They like the left side of the graph, but they don't like the right side. And the right side says there's a very small probability that this could get really expensive, but there's still a probability. Same thing with the left, which they like. There's a very small chance this could be really cheap, but it's a pretty small chance. And so you got to get comfortable with what you're putting into the simulation, but you also got to get comfortable with more than likely it's going to be in that 90%, but that 5% is still out there on both ends.
All right, let me ask you a question. So you've used all your statistics, whichever one you like to use, and you give somebody a quote on a work order, right? Well, things can change because obviously the data could change, and then you're in a whole. So how can you use that to help estimate? I mean, is there a 5%? Is that what that 5% is? Is like, hey, really, these are worst case scenarios if we get in there and we find X.
So if you have a project like this, which Gene and I have had a few, if they have paid to do this type of analysis, they actually have a really good idea what the long-term cost is going to be. And no, we don't go on a work order and say this is going to cost from 2.2 million to 6 million. Mm-hmm. We give them a price. We have very specific things in the work order that are going to be done for that price, and you put bounds on it. Mm-hmm. Because clients need some part of certainty. The best part about doing this kind of analysis in that situation is they now know some of the uncertainty and they know what could happen. And then we work to see what we can do to make those factors work in their favor.
In another way this is used, an investor might go looking at this and say, well, there's a probability that it's going to cost $6.1 million for this situation. So I'll go in and factor that into the purchase price, but then they'll come back to us and say, can you get it to 5.62? Because that spread then I can collect as my profit on this real estate deal. And we get that every once in a while. So they go, well, and that's a credible cost there, that it could cost $6 million to do the cleanup here, but it could also cost 5.62. So they're going to come back and say, what would it take to get to 5.62? Because I could make $500,000 on that deal. So,
and that's the beauty of the sensitivity analysis part of Monte Carlo analysis and cost estimating in general. You can now start pinning down what those specific factors are that cost most of the money. And so you tackle those.
Are we ready for the next slide? I just want to make sure that you hit all your graphs. Okay, example projects.
Yeah, so we wanted to give you some real world examples. So we've kind of talked about how we go about making these cost estimates. And so I think you get a flavor of some of the different things that we do here. Here we've got 3 different projects. One, and they're all actual real world examples. We were tasked to come up with the cost liabilities from two different oil companies that were merging. And obviously the question they wanted to see which oil company was going to owe the other one money on the deal. The other one that we did was oil refinery cleanup cost. It was for the SEC. So it was a publicly traded company needed to have a cost estimate to report to the SEC for their for that refinery, and then for that liability. And then the third one was chlorinated hydrocarbon cleanup, where the client had several different technologies that they could choose from, and they wanted this cost analysis for each one of those to make their decision on which one to go with. So the first one, the tale of two companies, I call it. I didn't want to use their actual graphs because it's obviously pretty confidential. So these cartoon drawings show you the first one. There is an actual of several different facilities, and we're talking from New York to Hawaii, where we looked at the cost from the cleanup cost from each facility. And as you can see there, it's a pretty normal graph. It looks just like it's supposed to look out of the textbook. We gave them expected value. Everything was good to go there. The second company we looked at, not so good. They had several facilities where it could have gone very expensive. So the uncertainty was really high. So the graph, if you look, is lower than the graph to the left. So company B had higher uncertainty, also potentially a higher liability on the deal.
And so what this really gets in, I'm going to give you the theory, but then I'm going to come back to reality just for Lance.
Thank you.
Theory, when you look at these things and you don't have data, do you assume a normal curve or not? And a normal curve is company A over there on the left, and not a normal curve is company B over on the right. And so company A, and in this case, we have all this data, so it's great, right? Company A has very small uncertainty. It's this nice normal curve. Like we talked about earlier, the right and the left tails are small. You want that. It gives you lots of certainty around a mean of how much it's going to cost. The company B on the right is everything that terrifies people about the environmental business. That long tail on the right side of the graph means that it could get very expensive because they don't have a very tight curve around the mean. So bringing this back to realistic, there's a reason that those two companies break down like that. Whether it's the type of crude and oils they deal in, or it's the type of landscape they operate on, or it's maybe more important, their culture and the way they go about cleanups. There's a reason that those two curves look that way, and that you would want to be company A and you have very tight certainty around your mean, whereas company B, it's sort of a crapshoot how much you're going to have to pay because they don't know.
Yeah, and that's what they ended up finding out from this exercise, was that the culture in company A, when they had a situation, they went out and found out how bad it was and reported it back. At company B, when they had a situation, they would stick their head in the sand. So they really didn't want to know, and they didn't want people to know.
What statistic is that?
That's called we live in uncertainty.
Scaredy cat.
Yeah, they didn't want to report it back to corporate or whatever their reporting mechanism was that they had a problem.
It gets interesting there because you don't want to have a corporate culture that forces somebody to be a company B. You want to know your liabilities. There's a message there, right? You need to work towards having a good corporate culture where these things get taken care of, because long term you'd rather look like A and not B.
And we find that in everyday situations. clients often assume that it's going to be a lot worse than it is. So moving on to the second example, it's a refinery example, and you might recognize the data on the right there.
I did right off the bat.
And this was a case where there were several different plumes. It was the reason there's two different costs in there. It was a transaction that occurred. And so we actually had a lot of really good data on this one. So the uncertainty was pretty low for a project that size. And we also had to estimate how much cost that the purchaser was due and the seller and things like that. So
to Gene's point there, the pre-1992 cost and the post-1993 cost, two different entities paying for two different things. And so a couple of things on this chart that we've talked about today already. Total expected cost is $6.117 million. Net present value of $8.177 million. So Lance, why?
Inflation?
Net present value, so either inflation or what day's money we're looking at. Today's, tomorrow's, yesterday's. All right, so we got one concept through, so we're doing well. To Gene's point,
Was a yes, I'm not going to lie.
to Gene's point on data robustness, it's an important factor in cost estimating. You can have days where you don't have enough data to produce an estimate. And so when you look at it, it's not very robust data. You don't produce an estimate. A known minimum value. Most clients don't like this when you tell them, well, it's going to cost you at least this much, and I have no idea on the high end. But that's comes from a lack of data. You get into most likely value, range of values, and expected values. Now we're in an area where most people can operate, but that's moving up on the robustness of data. To Gene's point on this, we had a ton of data, and I know this project, but I didn't work that much on it. But I can tell you, just looking at the statistics, if you look in the lower right-hand corner with a standard deviation of $163,000 on a minimum and a maximum in the $5 and $6 million, that's exceptionally small, which tells me that they had a ton of data to use, because that's not a lot of uncertainty. And so you can roll that back into your total expected cost. Those tails on this project are smaller than you might expect if you have more uncertainty. In fact, this one is in an area where you could most people could operate. And I'm not discounting how much $1 million is, but meanwhile, expected cost of $6 million and a high of 6.3 and a low of 5.4. That's pretty good. And that's what getting to the heart of sensitivity analysis can do for you. These guys have had a lot of time to work on this. And so if you work on the right factors and get more data on those, you can bring your estimating together.
So I know I've gotten phone calls from potential clients, and they've said to me before, and I'm sure this has happened to you, I just want to go into the reason why. Hey, we're into this project, and we're $500,000 in, and there's just no end in sight, and it was supposed to be X. So obviously they didn't have all the data, or their uncertainty was high, or what's the main cause of that? And that if you're out there, and what are some of the things you need to ask? Like, because you don't know what you don't know. If you don't know what to ask, then you're at the beck and call of whoever is giving you that number, I would imagine.
So when I hear those stories, most often people are operating off of limited data. Somebody went and took 10 soil samples and put 3 monitoring wells in. The groundwater plume goes past one of the monitoring wells. The soil isn't exactly delineated with the soil borings, but they just want to get moving, or They don't want to do any more data collection because it costs money, and they just want to get on to the cleanup, when really usually the biggest factor in those type of situations is how much soil, how far is the groundwater impacted, is it going off site. So the collection of data there is pretty valuable. And meanwhile, that takes communication, I think, with your client. The inability to have tougher conversations with a client is a lot of
And that's hard.
consultants'
I would imagine
bigger
that
weakness.
people hear these numbers and sometimes they like to go to the lowest number, but sometimes the lowest number costs the most.
Yeah. So if you've ever heard the term worst case scenario, so you say, well, they give you a cost estimate and it may be the best case scenario. And they didn't ask the follow-up question, what's the worst case scenario? And that's the range that you're dealing with. And if there's a lot of uncertainty, that's where they're getting in trouble. But also, and we're going to talk about this in the next example, if you want to flip to that, it's the sensitivity analysis, and I think we bounced around a little bit about on that. But it's what technology gets me to where I want to be. So if you looked at the Monte Carlo simulation and you talk about that, you go like, oh, that's a lot of uncertainty. What's causing that? So it also, when you do for instance, in the crystal ball scenario, they'll tell you that the factor that's causing the most uncertainty is the soil, the amount of soil in the project or whatever. So you can go back and say, well, if we knew how much soil is there, we could reduce the uncertainty. So the worst case scenario and the best case scenario get closer together.
Notice that doesn't always imply the expected value goes down. It might go up, but your uncertainty goes down, meaning lowest to highest. One of the things I really like about sensitivity analysis, and when you have a project that you do some estimating on, it can make some of the conversations a lot easier with the client, because rarely is it yellow iron, for instance, that is the thing you need to negotiate. Meanwhile, a lot of times they're the easiest because they're a person and they're there, but rarely are they the driving costs, for instance. Meanwhile, simplest project you could ever have. You have some soil, you need to dig it up, you need to haul it to the landfill. The most expensive things out of that whole scenario are how much soil, how far is the transportation, and what's the price at the landfill. So the questions shouldn't be, let's go negotiate with the yellow iron guys. It should be, let's go find a different landfill that's maybe closer, or maybe you can find a different landfill that gives you a lot better deal and maybe it's a little further away. And then reducing the amount of soil. So you're affecting those normal curves in those factors. And by doing that, you're changing your overall estimate. And the reason that I stress this with the sensitivity part is go after the biggest costs, because they're where you get the biggest reduction in your uncertainty.
So if you look at the next slide, so this is the final scenario that project that we wanted to talk about. This is one that Andy and I worked at, where the client received a cost estimate that was very expensive and would take 30 years to complete, and that didn't fit with their business model. Let's say they needed to get off the site, they need to get the project closed, so they came to us and said, is there another way to do it? And so what we did several different cost estimates for them, just like you saw previous. But what we did was got more granular and said, okay, instead of here's the expected value, this is what would happen if we use this technology. This is what would happen if you use this technology, et cetera, et cetera. And in this case, we presented them one of the scenarios that could speed the project up is to do a combination of Chemox and I think we used cheese whey, right?
Mm-hmm.
A couple of different injections on this project all at the same time. And if you can see here, what happened was that technology actually performed a lot better than we estimated. It was definitely in the estimate, but we thought there'd be a little bit more on the injection side. But it did achieve the cleanup goals very fast. And so obviously that was a success scenario there.
And so when we look at this project, the client didn't own this facility, and they were also having a discharge into a drinking water source, and they wanted the heck out of Dodge as quickly and efficiently, but as quickly as possible. So when we went back and looked at the technologies, the question in front of us was never, what's the expected value that this will take? It was, which of these technologies can get me out of here quicker? And they actually picked a technology that actually cost a little more than doing it slow. And it wasn't the most expensive technology either, but they picked the quickest technology. And it actually worked out very well. As Gene pointed out, I think we came into this around 2010 when the TCE concentrations were just about at the highest. Back to Lance's question, somebody spent a lot of money and then they came in after they had spent a lot of money and weren't getting the results that they wanted. And that's when we started running through these technology options, and the injections worked very well and brought TCE concentrations down. And it's a little unusual to not have another injection event, and it's not unheard of, but statistically speaking, it would be out on the left part of the tail, the cheap part that people like. So worked ourselves out of another job there, Lance.
Yeah. All right. Okay, so I guess our last poll question of the day, and it might be the most important, is who do you have winning the World Series? Let me launch this one real quick. Andy, you can't say yet, but it's one of the four I'm assuming you're going to say.
The Cowboys aren't on there.
The Cowboys are not on there, and neither are the Rangers, if there's any Ranger fans left.
Battle of the Coasts.
Yes. All right. Oh, we have some people that. All right, I'm gonna give 10
clearly
more,
not baseball fans.
I'm gonna give you guys 10 more seconds to close, and then actually, for the ones that did answer, it's pretty impressive. Okay, I'm gonna close it and I'm gonna share the results. So, 86% said Boston. So
Very good. Very good.
It looks good for Boston considering they are 2 games up, and the World Series is already going on. And they are playing the Los Angeles Dodgers. 0% for Los Angeles.
Oh,
Really?
And Gene, nobody said New York.
Huh.
So we figured there'd always be some bandwagon people out there. And 14% said Astros. I don't know if that's wishful thinking or if they think they still got robbed from the home run catch, but
or maybe you weren't specific of which World Series.
Baseball is going to reinterpret that interference call.
so. Okay, so that's going to really do it for us today. We do have some questions, but there's Gene and Andy's contact information. So if you guys have any questions, you can contact them, or you can also contact me. But we do have a couple of questions for you guys from the audience. Let me hide these results. So if you guys want to go ahead and ask some of your questions, go ahead and put it into your tab on GoToWebinar. Do you guys ever use the don't do anything technology in your cost estimating? First of all, what is don't do anything technology? It sounds like something that I would do when writing an essay in college, but what is don't do anything?
I think that's a great question because we do actually, because try to figure out, well, and we get that question every once in a while. What if I just don't do anything? What if I just leave it the way it is? And, you're probably going to have to do some reporting and things like that. And there's other factors that go in that. So I don't know if it's really an actual scenario, but we do use that every once in a while. I mean, or we'll put it in as a, because a lot of times a client will say, like, I've got this property, I'm going to be here forever. I don't feel like I need to do anything. What's the least amount of effort I can put into this?
I'm going to go back to Petroleum Company B. I'm going to bet that they had a lot of don't do anything scenarios, and that's how they got that liability out there. But I think you can take don't do anything a few different ways. Number one, W&M does a ton of risk-based closures, and that's not doing anything other than checking risk to human health and the environment. And so it basically says if the impact can stay there and it doesn't have an unacceptable risk, you leave it there. And so risk-based closures are good. The other side of that is there are also groundwater issues in certain places where there aren't receptors, that an acceptable way to budget something could be to use monitored natural attenuation. Now, it's not quite don't do anything because you're still monitoring to make sure that it's being broke down and there's stability, but that's another scenario where there's not a do something type.
And I mean, I'm sure that you can use the don't do anything technology, but you're just pushing your problems.
There's always
right?
There's always a liability to something.
And in some cases, it's going to get worse as time goes on. Maybe not, but okay. So there's two more questions. How many other technologies did you consider in the hydrocarbon example?
So I think I've slept a couple times since we did it, but I think probably on the order of 8 or 10. I mean, we got into some crazy stuff too, just to look at it.
Yeah, and I think what we ended up presenting them was the top 4.
Mm-hmm.
So yeah, we did, I think, consider everything under the sun, but then chose that 4 were the possibilities. So.
Yeah, there's probably on the order of 400 different things you could do. There's probably 10 that are actually executable and somebody wouldn't laugh you out of a room. And there's 3 or 4 that make some sense depending on what your driving variables are.
Well, I think I speak for the whole audience as thank you for not giving us examples of all 10 of us. But okay, so there are a couple of cute comments, but I'm not going to share them because they're quite creepy, actually. One of them, you want me to say what it is?
Sure. Is it about me?
How did Andy get so cute? So I don't know.
Maybe my wife's on.
Michelle must be in.
Say thank you, Mom. That's the
Thank
answer.
you, Mom.
So, all right, the last question of the day is: are you guys pro or against shirt pocket protectors?
Only when doing Bayesian Statistics.
Good grief! All right, guys, thank you for joining us. If you do have any questions, please contact us. We will be getting this webinar on our website, and I will be sending you an email with that link. You guys have a great day. We'll talk to you soon.